Can you hear me well? Hope yes. Welcome on the session about how to assure code quality in the Java universe. My name is Michał Kordas. I've worked for last 5 years in Luxoft as a Java developer that has particular focus on code quality and bringing all the features into absolute minimum. First of all, let's define what is quality. When you look for it, you may get multiple various definitions. There are some basic ones that say it's just about meeting requirements. Very, very basic one. There are also more mature, more advanced ones that are about, is it worthwhile product? Does it bring value? Definitely more mature, but in the same way, they are much more ambiguous. They are not giving you precise information what you need to do. Let's hope display will be fixed soon. We won't get this flickering anymore. I won't be talking about this kind of quality. So it's good that it disappeared, because you are all Java developers, right? You want some juicy stuff, not this undefined quality. So there is some ultimate elite that I'll talk today about. This is subtype of quality, but I think this is the most important aspect of quality in the software development. Let's look at this chart. This chart visualizes when this elite is high. So you start a new project, total greenfield. You go to conference, GeekCon, JDD, DevOps. You hear then TDD, BDD, Yagni, Tell Don't Ask, grasp principles, dry or die, right? You are inspired with it. Elite is high. Then you start reading books, building microservices, code simplicity, and so on. But when daily tasks take over, there is a very tiny difference between O'Reilly publishing house and Orly. So it's better not to confuse them when choosing what you read. When those daily tasks are getting more and more complicated, start saying, no thanks, I don't need help because I'm too busy. Don't run into this. Deadline is closer. Our enthusiasm decreases. And there's natural human tendency. So we made some tiny corner cutting. And there is window theory. It is proven that in districts that has more litter, more graffitis, broken windows, Kuba was also talking about this one, there is much higher probability of the crime, even serious one. So some graffiti may cause even violent murders. And the same happens in our software projects. It's enough to make those exceptions a couple of times, right? Allow some bad tests, some tiny hacks, some bugs that are not repaired. It can cause a lot of tests that are ignored, dead code, the application. We torture our code with this stuff. And it's then when acronyms get handy again, but they are different ones. We have snafu, situation normal, all full up. Fubar, which means fact up beyond any repair. Tarfu, it's cut here, but it means totally and royally freaked up. And actually, you can use any F word there you want. So don't let it happen. But actually, it's so often. If the Kraków was built by developers, the panorama to Grzegorzeckie and Mogilskie would look like that. Many skeletors and just one Błękitek on the right, once in a blue moon. Actually, productivity reaches total zero when we try to fix things that should never be broken. So this is what Uncle Bob was saying, and I agree with him. So it's important to have our productivity high. How we can do it? There is first law of development. No one is arguing with it, that lowering quality just decreases development time. There is also suggested rephrasing. You may choose just two. Free is not possible. Fast, cheap, or good. Why it is like that? Because of changes. If your project is not already dead, requirements change. When the requirements change, the code must change. So the code must be really well prepared for any change that may come. And our velocity directly depends on code quality. So if the quality is poor, our velocity goes to the zero. If it's high, then we at least stay at the same level, or even productivity may increase. And another quote from Uncle Bob. So the higher the quality, the faster we go. And the only way to go fast is to go well. How to achieve it? How to build quality into the code? One of the ways is just to use a fear. You tell your guys, code as there was a violent psychopath, some murderer that knows where you live and would kill you when it spots any issues with your code. And this happens, for me, pretty often. Oh gosh, this is ugly code. Who made it? I want to know this guy's address. And then I check, do annotate, it's me. So motivation may be various, right? Could be fear, could be just professionalism. But one of the reasons to maintain the code quality is just to do it for future me or future us, future maintainers of the product. Venkat Subramaniam says, he highlights another aspect of code quality, that it is inversely proportional to the effort it takes to understand the code. So it means it's all about readability. But how to measure it? You cannot do it by yourself. That's not possible. Only way to go is to give to your team members, to another team, and wait for some really harsh feedback. It could be really harsh. There is some unit of measure how the quality could be rated. It's just number of WTFs. And even if you have good code, expect a couple of them. That's a fallacy that for good code you won't get any comments. If you don't, if no one says WTF, it means the review was poor. Of course, expect more if the code is bad. But you can always improve. So the idea of code review is to make it really brutal, to make it deep, to make it fierce, cruel, stinging. This is the idea. And the reason is to improve the quality. The only thing you need to remember is just professionalism. If we have the same aim, we should focus on missed cases, hidden bugs, consistency, and your overall reading experience. If you cannot understand it, don't hesitate. Just tell this WTF or I cannot understand it, please explain to me, I have issues. And this is what should happen again and again and again. Another advice is to try to find something positive at least once, even if it is just that the code doesn't need to be obfuscated before the release. Now the question for you. Should we check on code reviews? Formatting, code style, some bug patterns? Is it important? Many people say no. this is not the point of code review. Ignore that. Right? I would say otherwise. If you see any issues with it, scream. But do not scream to the author of the code. It's just your process. You shouldn't worry about those at all. You should fix any style formatting issues, just minor bugs that could be automatically detected immediately, just after a few seconds or few minutes after they were introduced. So if this pops up on the review, that's definitely too late and you should change your process. But first of all, we need to know what's our style, what are those patterns, and so on. So there are two popular code style guides. One is popularized by Twitter, another by Google. And there are many interesting hints and advices to the Java developers as we are. Many of them are just common sense, minor things, but could be important, could lead to some major misunderstandings. For example, we should only use upper L when attaching to the numbers, long numbers. Why? Because depending on the font, it could be hard to distinguish, right? So if someone tells you that this should be upper L on the code review, that's too late. You should, even if you put lower L, this should be auto-corrected very quickly. There is, for example, check style rule that detects it and can run it just immediately after you've done the coding or while you are coding, just to detect those. Those style guides also define what is camel case. You could say, oh, that's obvious what is camel case. We know camel case great. We can read in camel case faster than normal text. But there are some tricky cases. What is iOS in camel case? IPv6. These get tricky, right? And in the projects, I've seen various types of camel case. The harder the case, different alternatives provided in the code. And this is distracting. We should just choose one approach. And code style guides just define what is camel case. And this is, again, common sense. So what is more readable? HTTPS XML DB connection written like that or like that? Which one do you choose? Second one, definitely. Right, so what's the rule? Treat abbreviation as a name always. First letter uppercase or lowercase if this is field name, and everything else lowercase. By the convention, now you know how to write getID, right? So get small, I uppercase, D lowercase. Keep this convention, you can automate it, and everything will be simpler, right? Any case is easy. So always choose those right-hand side camel case styles. Twitter style guide also mentions some good practices. Obvious, close your resources. So recently, we had an issue with our application. So what happened? After a few days of running, our machines were very, very slow. Started to be slow responsive. We checked our processes, heap usage of those processes, and all fine, nothing abnormal. But then we went into the operating systems and checked that the swap is absolutely full. Then what was the cause? It was hard to investigate because it appeared that native memory was allocated again and again and again. So it caused everything went in the swap and all operations on the machine were slow. And then we checked the code. Code on the first glance was correct. Yeah, resource opened and then closed. No issues with it. It was not highlighted. There was findbugs PMD was not. But as you may see, this has issue, right? So there is not just one resource open. There are more resources open, and only one of them is closed. It appears that IntelliJ has a rule for that, to detect such issues. It is so wise enough just to analyze the code, notices that there are many streams that could be not closed. But this rule is not enabled by default. I don't know why. Don't ask me. So the first thing you should do on Wednesday morning is just to enable it, because it can save you serious production issue. Then it gets highlighted. Then you know that it is not correctly closed. So spot bugs, PMD, all are successful with those cases. So do not rely just on single or just subset of those tools. Try to use a couple of them just to not run into false negative issues. I said spot bugs, but you probably more recognize for many years. What happened with it? What happened with this project? And apparently, the main maintainer of this project, Bill Pug, just disappeared. He's lost in this project, and it couldn't proceed anymore. So there was another group of guys that took this project, renamed it, put it into a new repository, and started over. How this is called in the software industry? It is buzz factor, right? So there was just one developer that is not fitting, but he just disappeared from the project, and it was. So if you define the buzz factor as a maximum number of people who can get hit by a buzz to not have the project in trouble, that's probably not the ideal definition. Look again. Maximum number of people who can get hit by a buzz have a project in trouble. So it's so easy to fulfill, right? Are those people really needed for the project? Probably there are just own. Architect, manager, QA manager, analyst, process champion, so on. Let's change so you hear me better. Okay. Oh, should be better right now. Thanks a lot. So if you eliminate those guys, probably will speed up. So that's the wrong definition of buzz factor. The correct one is minimum number of developers who need to disappear to send the project to such a horrible disarray, disorder, so it's not able to proceed. Let's move forward. As you see, that this resource issue was not detected by default by any tool that I already. But there is one tool that does it by default, which is called SonarLint. It is just a plugin to IntelliJ. Install it. It is pre-configured with defaults, and it highlights many issues like that. So you see, it's pretty smart. It sees resource is not closed. It reports it. Just within a second, type it, and you know something is wrong. So I recommend it can save you from bad things happening. Another thing that style guides say, which is obvious, is to release logs. How to do it properly. So if you can write the code like you take a log, you check some conditions, and you do a log. This is again, right? Because the log should be released on all possible paths. So when you run check style PMD, it doesn't report anything, but spot bugs catches it, right? It says that it does not release it. So again, we are safe here with spot bugs. IntelliJ has it as well. Why it is not enabled by default? I don't know. You should enable. The advantage of IntelliJ is that it exactly says what's the pattern. So you can look at those explanations in IntelliJ they are pretty descriptive. So they say, for example, that generally the pattern in Java that many style guides recommend is to take a log before the try, do some operations, and unlock it in finally. Then we are safe here. Twitter guides also mentions that we should keep units in our variable names. Again, this is common sense, but I've met in projects so many variables that were just poll interval, file size, and we struggle to understand what the units are about. Are those bytes, kilobytes, megabytes? Is there seconds, milliseconds, nanoseconds, and so on, right? So it's enough just to add some suffix to the variable name, and we already know where we are. Even better solution is just to create a type amount that binds number to some enum with possible various units, like time units, data units, and so on. Unfortunately, this is not something that could be automatically detected. So it's good to read those styles so we know those tricks, to remind ourselves that that's the practice that is worthwhile. Last advice from the as Java developers, we hate checked exceptions. They are so noisy. The signal to noise ratio is really poor. So I know that you want to burn those Java author of the checked exception is Java. You want to call idiot, but don't do it in the code. That's not professional. My recommendation is just to leverage it. We all know that they are poor. Those checked exceptions are a bad idea, but this is what it is. So at least use it when possible for better. And it is possible in many cases. We can just convert checked exception into unchecked and add some context. This is what I will repeat often, that catching exceptions and rethrowing them is really good idea whenever we have more contextual information to add to struct trace. Then any investigation of the exceptions that happened is much easier. So for example, IO exception, when it's thrown, it doesn't say with what file there was issue. We can convert it into unchecked and say, okay, we cannot read the file under this path. Google style guide is a good way that it is very precise. It says exactly what the formatting of the files should be. So there is a plugin to IntelliJ, to the Gradle, that is called Google Java Format. What it does, changes the default formatter to this one, and you may forget about any issues with formatting in the future. Because there is just one recommended way of styling the code. If you agree with an entire team, this saves you a lot of discussion, right? Big company uses it, follow the same. Also, the style guide provides XML file that you can configure IntelliJ with. So you won't code differently than the recommended way here. So this is nice way if you already, if you don't have style already and you want to take some, just take what is on the market. Google also has another tool, Error Prone. Have you heard about it before? Not too many. This is a tool that plugs into the Java compiler and can detect issues, common bugs in the Java code on the compilation stage. So you get the feedback very often as you compile the code. So it could be IntelliJ that you type and there is live compilation, you get the feedback, or in Gradle, when code is compiled, you get the issues. So this is immediate feedback, and also sometimes you can suggest. So it's not just about that is wrong and please correct it, but it tells you exactly how it should be corrected. So recommendation, you paste it, of course, and you're good. Let's take a look here. What's the output of this code? Think for a while. Any ideas? 1, okay. Any other guesses? So all the people are here agree that it is 1, right? Just 1 on the console. 99. All right. So 1 and 99. But if you run it, I did it half an hour ago, it is 100. Why? So this is again very common bug in Java. Flow in Java, you could say. So what we have here is a set of short numbers. We add it to the set. And then we remove the number that is just one slower. It is smaller by 1, right? But what happens here? What the Java compiler does, right? It sees that it is short variable, and while performing any operation on the short number, it promotes it to the integer. Always. Even if you put here cast to the short, even if you cast 1 to the short, it's still integer. It's really hard to perform math operation on the short number. You need to take it again into parentheses and cast to the short. Then it will work and print 1. Otherwise, this is int, it is promoted to big integer, so there are no such objects in the hash sets. There are only shorts. So this code is completely useless. Error-prone can detect it, IntelliJ can also detect it. So have the tools ready, because as you see, no one in this room knew the answer, but tools can do it for you. So as you see, error-prone, just while compiling Java, says, this is not correct in Java, please don't do it. There is another tool that I've recently discovered. It's called spotless. What spotless means in English? This is someone ideal, without any moral blemishes, without any faults. And the idea behind this tool is to detect any formatting issues, but not only to detect, because this is done by many tools like Checkstyle and others, but it can automatically fix any issue. So this is principle of this tool. So you don't need to spend any time on fixing those. There is always one command that fixes for you all the formatting problems. So after reporting, you can invoke command spotless apply, and it fixes everything. And as you see, it can run for many languages. Scala, Kotlin, and couple others, SQL, and so on, XML. But you can also apply it to any type of file you want. There are some basic checks like indentation should be done with spaces, tabs, some trailing white spaces, new lines, and so on. This is stuff that we should not be thinking. We should not be spending time on adding manually some new lines or changing tabs to spaces. This is a pure waste. Spotless solves this issue. You add this plugin once. If anything by some accident is wrong, you just invoke the command, it fixes for you, you commit. That's it. Another thing that may happen is that people have misconfigured IDEs. So someone uses tabs, some spaces. So even if the spotless is applied, it can fix things for you. You still need to think about it. You need to fix it, right? So there is some universal way to configure how the basic formatting should look like. It is editor config. It is detected by many tools without any additional plugins. You just add such simple file to your repo, and all of those tools automatically pick up those settings. And it's not possible to have the ID or your editor misconfigured. You just forget about formatting forever. One more file that we in our project have in all repositories is just Git attributes. Over some period, we noticed that dealing with LF and CRLF between Linux and Windows is not productive. We need to code specially just to handle both systems. Let's simplify the things. Let's agree that on every operating system we'll be using just LF. Because that's our production environment. This is where in what context our app works. So why to change it on Windows when we develop? So in the Git 2.10, it is enough just to have such simple file. You say, detect text files automatically, and for them do any normalization that is required, and configure it with Aleph. But before Git 2.10, such long configuration was required because there was a bug in Git. So Git also has a bug. It's worth to update it if you didn't know. That this wasn't working, and explicit list of binary files was needed. And this was really surprising for us, because sometimes we committed, let's say, JPEG or PNG to our repo, for example, to use in README, and it was partially broken. What is going on? It is working on my local machine, but after the push, it's just half of the image was displayed. How is this even possible? And this is the side issue of new line normalization. So we could prevent it in old Git by explicit list, in new Git just by this. And this is how we solved this problem permanently. There is technical debt metaphor that is common in our industry. Bad code causes more time and more costs for the project. We have less features, less money to develop further features. There is less money for coding, and this has caused this time pressure. And we loop again and again. So use tech debt only if you are conscious that you cannot take it without any limits. So if it takes time because of something, it must be well understood, and you need to pay it back by improving all the corners that were cut. So the technical debt is a difference between cost of change that is the most optimal and the actual. So if you do any corner cutting, you just need to be aware that you need to keep this technical debt on acceptable level, because otherwise you may go bankrupt. Another quality-related stuff is recruitment process. Who should we hire? If we review the job offers, we may get the impression that companies are looking for some virtuosos, rock stars, just masters in Java, hardcore programmers that solve all algorithmic problems within minutes. And the people that are just intuitive, practical, simple-minded don't have chances. I would say this is a big risk. Why? Because of Petrov principle. What it says, that complexity of our projects, of things we do, increases rapidly. Increases to the moment when no one is able to understand what is going on further. Only then it stabilizes on some level. So the more clever people you hire to your project, the more complex your project is. And you run into the trouble that you can only hire more and more clever guys until you totally fail. So another solution is just to prefer simple guys that just are led by intuition, by empathy, that ask many questions and do not understand many things at once, right? Those will reduce complexity, introduce simplicity in your project, and simplicity is an art. So I would say those simple-minded people can be more skilled and more useful for the projects than those ninjas and rock stars. And Trisha tweeted, it is part of talk from Java 1, that if you hire this kind of guys, the only thing you could end up is dead bodies and smashed guitars. Don't do it. Leonardo da Vinci said that simplicity is the ultimate sophistication, not complexity, not cleverness. Let's summarize. Do thorough code reviews. Let them be harsh, brutal, cruel. Everyone must understand it, that this is for good. Do not worry. Create your own style guide if you are mature enough, or reuse the existing one. Because there are many tools on the market that could help you enforce or even totally forget about things, so you could focus on code review on more important stuff that I mentioned. You should use multiple tools for the code quality. Style, PMD, Spotbug, Spotless, Sonoralint, Error Prone. In my experience, only combination of all of those give you the high probability of avoiding some errors. It is hard to configure them. Not all of them have reasonable defaults. Many rules have some bugs. For example, I was not able to have issues detected by Sonoralint on those lock not properly unlocked. They claim they have this rule, but it was not working. So there are bugs there. Only by enabling many tools you can minimize probability. Do not let history repeat with the find bugs. Have always many people that know what the project is about, that knows the context, that knows the why of the project. So your buzz factor is maximized. You share your knowledge, mostly by pairing, by code review. And the principle that is outcome of my talk is keys, very long keys. It means keep it simple, straightforward, even stupid simple, small, you see. There are many aspects of code quality. So there is small implementation, performance, numbers, node application, code standards applied. Those are low level. And as you may notice, I'm not talking a lot about testing. The testing is something obvious that you should do. I was not mentioning it because the code quality is much deeper than it. Of course, you should test, but if you rely just on testing and you do more and more testing just to improve the quality, it's like waving yourselves more often if you try to lose weight. This doesn't help much. There are much more things that you should take care of than it. So let's reveal this ultimate elite. Low-level stuff that is visible on the code review or could be detected by those tools. There are 5 features that derive from those basic things. Analyzability, modifiability, testability, reusability, modularity. So all the elites go into the ultimate one, which is maintainability, the ability to make change. And we all do Agile. And as Venkat says, we cannot do Agile if our code sucks. Thank you very much.
Okay, thank you.
Do you have any questions? I have gadgets for you for questions.
So, any questions? Nobody. Really? Okay. Everybody's hungry.
No one wants gadgets? I know there is lunch waiting for you. Anyway, I'm here for a couple more minutes more, and afterwards I'll be on the Luxoft stand. There are a couple more guys from our company there if you want to talk about code quality or about other things. We are there.
Okay, thank you
Come
very
to us.
much. And please don't forget to assess stock at the Evender app.
Yeah,
Thank
I'll
you
be very
much.
grateful for any feedback you may have.
Okay, thank you very much.